Imagine standing inside a factory where a machine no larger than a dining table could change the outcome of an entire battlefield thousands of kilometers away. Military drones may look sleek and silent in the sky, but every one of them begins as ordinary raw materials pulled from deep beneath the Earth's surface. Hidden behind reinforced doors and strict security lies one of the most advanced manufacturing processes ever created. Today, you're about to step inside that world, and what you'll discover will change the way you see modern engineering forever. Most people imagine drones appearing fully assembled inside secret factories. But here's what nobody tells you. A single advanced military drone contains thousands of precision-engineered parts sourced from multiple continents. Carbon fibers, aerospace aluminum, titanium, rare earth magnets, semiconductors, and optical glass all travel incredible distances before they ever meet on the production line. And this is where the journey truly begins. Think about this. The lightweight frame that lets a military drone fly for hours often starts as carbon fiber. Much of the world's aerospace-grade carbon fiber comes from Japan and the United States, where manufacturers convert polyacrylonitrile fibers into carbon by heating them above 1,500 degrees Celsius, 2,732 degrees Fahrenheit inside oxygen-free furnaces. The result is a material nearly 5 times stronger than steel while weighing only a fraction as much. The drone's internal skeleton depends on aerospace-grade aluminum and titanium. Bauxite mined in Australia and Guinea eventually becomes aluminum with purity exceeding 99.7%, while titanium extracted from mineral sands in Australia, South Africa, and Canada delivers incredible strength under extreme temperatures. Although titanium can cost several times more than steel, engineers gladly pay the price because every gram saved increases flight endurance. Now imagine the drone's electronic brain. Tiny silicon wafers begin as ultra-pure quartz before they undergo dozens of manufacturing stages inside spotless clean rooms. Some processors contain billions of microscopic transistors, so small that dust particles appear like giant boulders beside them. That's why workers wear full clean room suits, because even a fingerprint can destroy months of precision manufacturing. The drone's powerful electric motors rely on rare earth magnets containing neodymium and dysprosium. These elements often originate from mines in China before traveling through refining facilities capable of producing magnets with extraordinary magnetic strength. Without these tiny components, the propellers would never generate enough thrust to lift sophisticated cameras, sensors, communications equipment, and guidance systems into the sky. But the supply chain hides another challenge. Every shipment travels thousands of kilometers by cargo ships, freight trains, and secure transport trucks before reaching final assembly. A single delay can halt production worth millions of dollars per day. And what happens once every one of those materials finally arrives behind the factory gates is even more extraordinary. Now the real transformation begins. Inside a tightly controlled aerospace factory, every raw material follows a precise schedule measured down to the second. Workers and robots move in perfect coordination, because even a tiny mistake can affect a drone traveling hundreds of kilometers from its launch point. Most people never see this level of precision, but every successful mission depends on what happens here. The process starts with a carbon fiber airframe. Sheets of carbon fiber fabric are carefully laid inside precision molds before being infused with aerospace-grade epoxy resin. The molds enter massive autoclaves where temperatures climb to approximately 180 degrees Celsius, 356 degrees Fahrenheit, under pressures of 6 to 7 bar, curing the material for nearly 2 hours. Inside the chamber, heat and pressure fuse hundreds of layers into a single structure that feels unbelievably light yet incredibly strong. Once cured, the A-frame moves to a 5-axis CNC machining center. Diamond-coated cutting tools spin at speeds reaching 20,000 revolutions per minute, trimming every opening for sensors, antennas, and electronics with tolerances tighter than 0.05 millimeters. The machines create a constant high-pitched sound while fine carbon dust disappears instantly through powerful extraction systems, keeping the air perfectly clean. Next comes the heart of the aircraft. Precision technicians install the flight computer, encrypted communication modules, GPS receivers, radar components, and advanced navigation sensors. Every connector locks into place with carefully measured torque, and every cable follows a predetermined path to eliminate electromagnetic interference. What looks like ordinary wiring actually controls millions of calculations every second once the drone takes flight. The propulsion system arrives next. High-efficiency brushless motors pair with precision-balanced propellers spinning at nearly 8,000 revolutions per minute during testing. Powerful lithium battery packs or fuel power propulsion systems undergo separate inspections before installation because even the smallest imbalance could create dangerous vibrations in flight. The factory suddenly fills with a sharp whine of electric motors as engineers begin their first operational checks. Now comes one of the most fascinating moments. Technicians mount stabilized electro-optical cameras, infrared thermal imaging systems, laser rangefinders, and advanced targeting sensors beneath the aircraft. Each sensor must align within fractions of a degree to ensure perfect accuracy. What happens next surprises even experienced engineers, because the drone is finally ready to prove whether every component can work together as one. Before the drone ever sees open skies, it enters ground testing stations packed with diagnostic equipment. Engineers simulate flight conditions, verify encrypted communications, check navigation systems, and monitor thousands of data points every second. One failed sensor or software error sends the aircraft back for repairs immediately. And that's only the beginning, because the quality inspections waiting ahead push every drone far beyond ordinary manufacturing standards. Now the factory shifts into its most advanced phase. This is where raw engineering becomes intelligent flight. Inside silent, clean test rooms, drones are no longer just machines. They become data-driven systems capable of reacting to their environment in milliseconds. Every circuit, every sensor, every line of code is pushed to its absolute limit. Robotics now take over precision calibration. Laser alignment systems scan the drone's frame down to micron-level accuracy, smaller than a human hair. In some systems, tolerances are held within just a few microns, ensuring that navigation sensors, gyroscopes, and stabilizers all work in perfect harmony. Even a 0.1 millimeter misalignment could cause flight instability at high altitude. Then comes software integration. Millions of lines of code are loaded into the flight computer, controlling everything from autopilot stabilization to encrypted communication channels. Artificial intelligence systems process real-time inputs from cameras and sensors, allowing the drone to identify terrain, track movement, and adjust its flight path instantly. It's not just hardware, it's a thinking machine built from algorithms and silicon. Now the testing phase becomes extreme. Engineers place drones inside wind tunnels where air speeds reach over 200 kilometers per hour, 124 miles per hour. Temperature chambers simulate freezing high-altitude conditions below minus 40 degrees Celsius, minus 40 degrees Fahrenheit, and desert heat above 50 degrees Celsius, 122 degrees Fahrenheit. The drone must survive every environment on Earth before it is cleared for deployment. Failure here means redesign, no exceptions. But one of the most critical moments happens in electromagnetic testing chambers. These sealed rooms simulate signal jamming conditions where communication can be disrupted. Engineers test whether the drone can maintain stable navigation even when GPS signals are weak or blocked. The systems must adapt instantly, switching between redundant navigation methods without losing stability. Finally, the ultimate human versus machine moment arrives. Experienced engineers manually inspect every subsystem, something no robot can fully replace. They listen to motor vibrations, check connector resistance, and physically examine structural joints. In a world of automation, this human intuition still catches rare flaws that machines miss. Every year, the world produces thousands of advanced military drones across a tightly controlled global defense industry. These machines represent billions of dollars in investment, shaping modern surveillance, reconnaissance, and defense capabilities. The market continues to expand as nations prioritize aerial intelligence like never before. The industry is dominated by a handful of technologically advanced nations. Over the last decade, production has rapidly scaled due to automation, AI integration, and miniaturized electronics. What once required massive aircraft factories can now be achieved in highly specialized facilities producing faster, lighter, and more intelligent unmanned systems. One shocking fact is that a single advanced drone can contain over 1,000 individual components, each requiring strict quality certification. Another surprising truth is that testing alone can take longer than actual assembly. And perhaps most surprising of all, even a tiny software update can completely change a drone's mission capabilities overnight. Now step back for a moment and think about what you've just seen. A military drone is not just a machine. It is a result of mining, chemistry, physics, robotics, software engineering, and human precision, all working together across continents. From raw Earth to intelligent flight, every stage builds on the last until something extraordinary emerges. And here's a final thought that changes everything. The next time you see a drone silently moving across the sky, remember, it was not simply manufactured. It was engineered from the ground up with extreme precision, tested against impossible conditions, and perfected through science that pushes human capability to its limits. What looks like a simple flying machine is actually one of the most complex creations on Earth. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.